Hello, I'd like to talk about overloading and polymorphism. So both of these terms might seem scary at first, but they're really quite simple and they're actually a programmer's best friend. Okay, let me prove it to you. Overloading and polymorphism are two related but very important concepts. They're crucial for programming in Java and object-oriented languages. The word polymorphism means many forms. Okay, so these are related terms, so both mean many forms in some way or another. In Java, both of these terms mean many versions of the same method. Okay, and that's certainly how we'll be applying them. They're extremely useful, and as a programmer, they're your best friend. So you should become comfortable with these, use these in your own work, and very soon they'll become second nature. Overloading is where you have multiple methods with the same name, but with different parameters. And Java determines which method to call at compile time based on what values are passed to the method. So the values that are passed and the types of values and the order they're passed in. That's how Java determines which method to invoke. And that's done at compile time. Okay? And that's also called early binding because it's done at compile time before you run the program. So that's why it's early binding. With polymorphism, you've got multiple methods with the same name, but which one is called depends on the type of object that is involved in calling the method. So it's all to do with the context of the call. And Java determines which method to call at runtime. So that's late binding. It's after the program's compiled, while the program's running, that's when Java determines which method to invoke or call. Okay, so they're both to do with having multiple methods with the same name, but which one gets called depends on what you pass to the method or how you invoke the method. Okay, and they're very, very useful. Both of these techniques are very useful. Let's look at an example of overloading, and we'll look at the AWT text class. So we could have used the swing text area. We could have used the J text area, but I've just used the AWT text area here just to keep the code a little bit simpler. Okay, so let's say we've got a text area, my text area equals new text area. I'm going to pass through a blank string. The dimensions of the text area, 10 rows, 30 columns, and scroll bars going in both directions. Okay, I'm going to create another text area. I'm going to place the hello world text in the text area and same dimensions as before. I'm going to create a third text area and just put the string hello world in it. And I'm going to create a fourth text area, and that's just going to have the dimensions. Okay, so I'm creating 4 text areas here. Okay, and all of those calls are valid, and each of these is actually invoking a constructor. We've been using these components or components like these for quite a while now, and each of these lines of code, there's 4 lines of code there, each one of those involves invoking a constructor, the text area constructor, and each constructor has different parameters to allow flexibility for the caller. In other words, the programmer who's invoking or using the class. The caller, in other words, the programmer or the method that the programmer is developing, can use whatever method is best based on what they are trying to achieve and what inputs you have or what you can provide. Okay, so you can create text areas in a whole bunch of ways, and there's 4 of them. Okay, so that we've actually got there's actually many constructors in the text area class, and one takes a string, an integer, and the scroll bars parameter, which is also an integer. Okay, another one takes a string, an integer, and an integer. Another one just takes a string. Another one just takes 2 integers. Okay, so there's at least 4 constructors that we know of in the text area class, just in that example. They're all different methods, but which one gets invoked depends on what values are passed to the method or the constructor and the order that they're in. So when it's string, integer, 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 then a particular constructor is called. Okay, so that's how overloading works. So in this example, each constructor has many forms. There's at least 4 constructors in the text area class. We know that just from that example, providing flexibility to users of the class, allowing them to supply whatever information they have, and using default values for any items that are not supplied. For example, the scroll bars parameter. If you don't provide it, Java will give you the default value, whatever that might be. This is an example of overloading in action. Which method is called depends on the values passed to the method, and a constructor is just a method. So which values are passed and the order that they're passed in. Okay, so string, integer, 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 a particular constructor will get called. And of course, polymorphism and overloading are not limited just to constructors. Any method, or just about any method, can be polymorphic or overloaded. Okay, so let's look at polymorphism now. So polymorphism is very similar to overloading, but instead of the parameters determining which method is called, it's the context of the call. What's the type of object that's invoking the method or being involved in the invoking of the method? Okay, so let's look at one example there, the add method. And we've been using the add method a lot throughout this course and the prior course. And that's a good one to look at, but there's many other methods that are polymorphic in Java, and we can create our own just as easily. So the add method adds a GUI component to the user interface. For example, add a mount text field. We'll add that text field to the interface or to a layout or to a panel or something like that. You can add a GUI component to a panel, bottom panel.add, visa checkbox. That adds a checkbox to the panel. You can add items to a choice with the add method. So here we're adding a string to a drop-down or a choice component. And we can add menu items to menus, add file menu to the app menu, and so on. Okay, so these methods all have the same name, but which one is invoked depends on the context. So here a panel is involved in the invoking, so it's adding a GUI component to a panel. Here a choice is involved in the invoking, so a string is added to the choice. Okay, and so on. It's just like that. Okay, and here we've got a menu item or a menu being added to an application menu, so it's the add menu that's to do with the add function that is to do with adding menus to other menus and so on. Okay, and we've used add for many other things, so that's just 4 examples. Okay, so the add method has many forms, providing flexibility for callers of the method. In other words, programmers who are writing code to use these sorts of functionalities, adding GUI components to forms and so on. Which version of the add method is executed depends on the context of the call and the parameters provided. So that's polymorphism. For example, if a string is passed and the object is a choice, then the add method that is invoked is the one that adds a string to a choice. If a GUI component is passed and the object is a panel, then the add method adds the GUI component to the panel, and so on. Okay, like we just said on the previous slide. So that's polymorphism in action. So polymorphism and overloading are incredibly useful. For example, in the case of the add method, add is all a programmer needs to remember. You don't need to remember that there's a whole heap of different add commands and they've all got different names. There's just one add method, well, there's just one name you have to remember, that's add, and you just remember the parameters you need to pass and how you invoke the method. Okay. If it wasn't for polymorphism and overloading, then programmers would need to remember dozens of commands like these. Add a text field, add text field to interface, or add text field to GUI, or something like that. Add item to choice, and you'd pass it a string. Add menu item to menu, and you'd pass it a menu item, and so on. So what would you rather remember? Dozens or hundreds of commands like this, or just add? And of course the answer is just remember add. That's the beauty of polymorphism and overloading. So imagine how horrible programming in Java would be if that's what we had to do. Remember all these dozens of different names of methods, all with different cases and all sorts of things. It'd be very difficult to program in Java then. All we have to do is remember add when we want to add something to something else. So it's very easy. Java makes it easy because of polymorphism and overloading. So in conclusion, overloading and polymorphism are actually a programmer's best friends. Okay, they save you a lot of work, they save a lot of complexity. Okay, and they're very useful. Use both of them in your work at every opportunity, and once you get some practice applying them, they will become second nature very quickly. Okay, so I hope that was useful. Thanks for watching.